In this example, we'll look at the chi-square test of homogeneity. Suppose that 100 randomly selected family households and 200 randomly selected single-member households were asked to identify which automobile types they owned. Do they own a car, a truck, a van, a motorcycle, or none? Then we can ask the question, do families and single-member households have the same distribution of automobile types? So below, the data is summed below in our contingency table. Now we should make note of this. This is where the data is. This is what you're going to enter into matrix A. This is 2 rows by 5 columns. So just make a note of that when you're putting it in. All right. So first, let's state our null and alternative hypothesis. For the test of homogeneity, the null hypothesis says that the distributions of autotypes for families and single-member households, these are our 2 different populations, families and single-member households, the null hypothesis says that they are the same, and then the alternative hypothesis will say that the distribution of autotypes for families and single-member households are not the same. We need to state the level of significance of the test and circle what type it is. This is, again, it hasn't been told to us, so we will assume that alpha is equal to 5%, 0.05. We'll be using the chi-square test, which is always right-tailed. From there, we'll be able to draw the diagram and determine the critical value for the rejection region. So over here, we have the chi-square distribution. We know that this is going to be 5%, so we come over here, right-tailed. In here, we want this to be 0.05. So we'll be looking for chi-squared 0.05. We'll need to know the degrees of freedom. The degrees of freedom are row minus 1 times column minus 1. We have 2 rows and 5 columns. This becomes 1 times 4, which is 4. So when you go to the table, then you can find the critical value from the table, and that will be 9.488. After that, we'll find the test statistic, and we'll let our calculator take care of it. Remember, chi-squared is equal to the observed minus the expected values divided by the expected. And we would have to do that for every single cell. So this is definitely where we'll let the calculator handle it. In matrix A, you will enter the contingency table from the first page. Remember, it's a 2 by 5. Then you'll go to stats and then tests, and you'll access the chi-squared test. Enter the observed values into A, and the expected values go into B. Remember, you leave that blank, and then he'll hit calculate, and when you do, chi-squared will be given to us as 62.92. All right, so if we come back up to our diagram up here, 62.92 is way out here and very clearly inside that rejection region, so we will clearly be rejecting the null hypothesis, even without knowing the probability associated. However, our calculator will tell us the associated probability. It tells us that that is 7.08 times 10 to the negative 13, and this is effectively 0. So whichever way we want to do it, it doesn't matter, either based on the probability, which is effectively 0, our p-value, excuse me, that is less than alpha, or because our test statistic, 62.92, is greater than our critical value, 9.488. The point is here is it's very clearly inside the rejection region. We will reject H sub 0. And then lastly, we can translate this conclusion into a formal sentence. At the 5% significance level, there is sufficient evidence to support the claim that the distributions of autotypes for families and single-member households are different. Now, what we should note here is that while the test tells us that they are different, the test does not tell us how they differ. So at that point, you would have to go in and look and do other tests to try and figure out how exactly they are different.